To work out which form of center to use, i.e. median or mean, what we can do is actually get an idea of the distribution or shape of the data. Now, we can get a visual on that by using some of the statistical graphs that we've looked at so far. So the first form or shape that we've got is what we call symmetrical data distribution. Often this data is normally distributed. And what we're looking for is symmetrical or approximately symmetrical is if I can draw like a curve over the top of it, like so, and imagine a midline built down the middle of it. We've got the same amount of things on the left and the right, okay? And this is then classified as symmetrical data. This one here also follows that same trend. So if I look at that, curve over the top of the data, line roughly down the middle, same there as there, approximately. So we would say that this is approximately symmetrical. Okay, and finally this dot plot here has the same sort of thing happening either side of the middle values, which is centered around sort of 89, 90. Okay, so we've got positive skews, okay? So for positively skewed data, what we've got, I call this tail at the top. Okay, so if I draw one of those things over the top of this, I get the tail at the top, okay? Line over the top, tail at the top, line over the top, tail at the top, or the tail is off at the higher values, so it tails off at the higher values. So this is what we call positively skewed data, okay? We've also got negatively skewed, which it won't surprise you, is the opposite to that. Okay, so this is what I think of. I think of tail at the bottom. Okay, so again, if I imagine a curve over the top of that, tail at the bottom, tail at the bottom, tail at the bottom. Sometimes a distribution has outliers. Okay, an outlier is an unusual value or multiple unusual values, okay? So that's what we're looking for when we're talking about outliers is an extra high value or an extra low value or multiple extra high or low values. So when describing the shape of the data, it is important also to comment on whether there's a possible outlier. Now we'll be able to confirm that later on. I'm going to give you a calculation to tell whether a piece of data is an outlier, but at this stage we're just going to say that something would be a possible outlier. For example, this data is positively skewed. Okay, now why? So we've got the tail at the top, so we call that the positive skewed, and possible outlier at 425. So this one here we're going to say is a possible outlier, just because it just seems unusual compared to the rest of the data. What do we got? Money spent on soft drinks, okay, and frequency of responses. I hope this is per year. This is $425 spent on soft drinks. I hope that's not like per week or something like that. But yeah, possible outlier here. One person responded by saying they spend between $425 and $450 per week on soft drinks. Okay, so we're going to say that that person is probably an outlier. Okay. All right, so for the distribution shape of the following histograms, or describe it. So this one here, we've got tail at the top. So we're going to say that this is positive skew. This one here, roughly the same on either side. So we're going to say approximately symmetrical. This one here, very clear tail at the bottom. This one here, bit hard to sort of describe this one. I think you could go either way, tail at the top, approximately symmetrical. I'm going to go approximately symmetrical. What we try to do under assessment or exam conditions is not put one that's line ball and put one that's either a clear, approximately symmetrical, positive or negative skew. You're going to get one of these ones here. So this one here is up for debate a little bit and could be taken either way. So yeah, approximately symmetrical is what I'm going to go with, but it could be equally argued that the skew might be tail at the top. So it could be positive skew, but I think it's most closely approximately. All right, so here's our example. Data is collected from 20 people randomly about the number of times that they use the internet in a given week. Right, so I think we've hit this data before. What I want you to do is type that data into your calculator. I'm going to pause the video and put it into mine. Okay, so data's in. Let's go with the questions now. Enter the data into the calculator and rearrange the list in ascending order. So edit, sort, ascending. One list, list one, please. There it is. Right, so what we can see here is got mixed bag of responses here. This person here used the internet twice in a week. Not sure where they live. This person, mad for it, 120 times per week. I'm not sure what constitutes a use, but 120 is that one. All right, explain why the data set would need to be grouped for a frequency table and histogram. Well, again, check it out and imagine it. Like we've got a 2, then nothing in 3, nothing in 4, nothing 5, nothing in 6, 7, 8, 9, then 2 10s. What we're going to have is the world's worst histogram. Okay, so what we need to have happen is we need to shrink up this data here and group these values here so that it compresses them a bit. Okay, so what we're going to say here is the data has a wide spread, so needs to be grouped. All right, identify the size of the class interval and appropriate start value. All right, how are we going to do this? Well, what I can see here is we've got like maybe 0 to 10, 10 to 20, 20 to 30, 30 to 40 perhaps. So that's going to give us 4 groups plus this 120 over here. I don't know, I think we need to target a few more groups than that. All right, so what we might do is try maybe a 7 or an 8. Okay, so I'm going to start, I'm going to try a 7 initially and see what happens with a start value of 0. Okay, so recall the way we do this is we go set graph and setting. Okay, now this allows us to put in place the settings so that when I ask it to graph it, it goes, all right, what are your settings? So we're going to go histogram. Okay, now the data is in list 1 and it's not in a frequency table. So we're going to hit set. All right, now remember all that does is sets the properties so that when I hit this graph button, it goes, what kind of chart do you want? And it looks at the settings for stat graph 1. Right, so we're going to hit it. All right, our start value is 0, and we're going to try stepping it by 7 and see what it actually gives us. So we hit OK. All right, so what we can see here is we've got this one person who used the internet 120 times in a week, and everyone else is clumped down here. Now, how many bars have we got here? 1, 2, 3, 4, 5. That's not too bad, and it's a good way to get an idea of the shape. Let's maybe try to shrink it down a little bit further. So I'm going to hit the cross on that graph. Try it again, starting at 0 with a step of 5. Okay, not much better there. What we can see here though is the clustering of values at, up here with an outlier. So, describe the shape of the histogram, measure of distribution. Okay, so what we're looking at here is how this data is distributed, and what we can see here is we've got the tail at the bottom. So I believe that this is a negative skew with one possible outlier, okay, which was 130. Okay, use the CAS to find the values of mean, median, and mode. All right, let's go get rid of that. Calc, one variable, and okay. Right, our mean was, according to the calc, 24.05, 24. Our mean, we're looking for med, is 20, and our mode, I think, will be 10, will it? So mode n is 4. That means we've got the number of modes we have is 4, and the frequency of that is 2. So we're going to say that the mode, there is no mode, because the calculator is telling us we've got 4 different most frequently occurring numbers. Now, let's have a look at the mean and the median and why these centers are 2 different things. Okay, so in this case, we're going to say that the mean is affected by the large value 130, because remember what that is, that comes into the calculation of the mean. Remember, all of these numbers are added together, okay, and divided by the number of numbers, so it's going to include the calculation on the 120, okay. The median is independent of the large value. That is, that large value doesn't come into play. All median does is it goes, I'm just going to find what's in the middle of the data, and it doesn't care about that value there. And I can show you some more extreme versions of this. So what I'm going to do is go down to this 120. Let's say I've got a customer here in the data here who just is mad for the internet, like uses it 5,000 times in a week, just mad for it. 120, no, 5,000. Okay, so what I'm going to do is go, oopsie, what did I do there? No, I didn't do that. Calc one variable again, and we're going to note the value of the mean and the median. And what should happen here is the median is just going to increase even more. So currently it's 24, median is 20. It's going to increase. Now think about what might happen to the median here. It shouldn't change. The center should still be the center regardless of the fact that that's now changed to 5,000. Let's see what happens. Right, so our mean now is 268, all right? Just because of that person, mad for the internet, 5,000 times in 1 week. 268, what's our median? Still 20, okay? So explain which of the mean or median is the appropriate measure of center for this set here. We're going to conclude that the median is better as it is not affected by the possible outlier. All right, so go on with the questions now. There's exercise 9B, and obviously there's a few more questions that you'll need to do.